In the 2002 National Electrical Code, Section 400.7b addresses fixture wiring, stating that flexible cord may be used only for wiring of fixtures where specifically permitted by other code sections. Section 400.11 further clarifies that flexible cords and cables shall be used only for pendant fixtures and the wiring of fixtures. Section 410.14c reiterates that flexible cord may be used for the wiring of fixtures with exceptions noted in 400.7b. Exception number 1 states where used as permitted in 400.7b. In the 2002 NEC, this meant that SJ cord could be used for fixture whips and exposed ceilings, but only for incandescent fixtures that did not require a plug. Fluorescent fixtures required a plug and could not be wired with SJ cord. Now let's examine the 2017 National Electrical Code. Section 400.7 bone addresses fixture wiring, stating that flexible cord and armor cable shall be permitted for wiring of fixtures and for connection between the fixture and the junction box, raceway, or outlet. Section 400.11 states that flexible cords and cables shall be used only for pendant fixtures and wiring of fixtures. Section 410.14c indicates that flexible cord may be used for the wiring of fixtures. Again, exception number 1 references where used as permitted in 400.7b. This means that according to the 2017 NEC, SJ cord can be used for fixture whips and exposed ceilings for both incandescent and fluorescent fixtures. To summarize, the key difference between the 2002 and 2017 NEC lies in the permissibility of using SJ cord for fluorescent fixtures. The 2002 NEC restricted its use to incandescent fixtures not requiring a plug, whereas the 2017 NEC allows its use for both incandescent and fluorescent fixtures. When working with electrical installations, it's crucial to consult the latest edition of the NEC and local codes to ensure compliance and safety. Always refer to the specific code language and seek clarification from a qualified electrical inspector when needed. It's always a good idea to check with your local authority having jurisdiction, known as the AHJ, on any electrical installations. Let's delve deeper into the specifics of each code section to understand the rationale behind these regulations. In the 2002 NEC, the restriction on using SJ cord for fluorescent fixtures was likely due to concerns about the heat generated by fluorescent ballast and the potential for the cord's insulation to degrade over time. Incandescent fixtures, especially those without integral ballast, typically produce less heat, making SJ cord a more suitable option. However, advancements in ballast technology and cord insulation materials have led to changes in the 2017 NEC allowing for the use of SJ cord with fluorescent fixtures. The 2017 NEC broader allowance reflects a recognition that modern SJ cord is capable of withstanding the heat and environmental conditions encountered in typical lighting installations. It's important to note that the NEC provides minimum standards for electrical safety, and local codes may impose additional requirements. For example, some jurisdictions may restrict the use of flexible cords in certain types of occupancies or require specific types of connectors or support methods. Therefore, it's essential to consult with local authorities and qualified electricians to ensure compliance with all applicable regulations. When installing fixture whips using SJ cord, several factors should be considered to ensure safe and reliable installation. Firstly, the cord must be properly sized for the load it will carry. The NEC provides tables that specify the allowable ampacity of flexible cords based on their gauge and insulation type. It's crucial to select a cord with an ampacity rating that meets or exceeds the fixture's current draw. Secondly, the cord must be protected from physical damage. This can be achieved by using raceways, cable trays, or other approved methods of support and protection. The cord should also be securely fastened to the fixture and the junction box to prevent strain on the connections. Thirdly, the connections must be made using approved connectors. Wire nuts, terminal blocks, or other suitable connectors should be used to ensure a reliable and secure connection. The connectors should be properly sized for the conductors and tightened to the manufacturer's specifications. Fourthly, the cord should be installed in a manner that prevents it from coming into contact with hot surfaces or sharp edges. This can be achieved by using standoffs, clamps, or other methods of separation. The cord should also be routed away from areas where it could be subjected to abrasion or impact. Fifthly, the installation should be inspected by a qualified electrical inspector. The inspector will verify that the installation complies with all applicable codes and regulations and that it is safe and reliable. The inspector may also perform tests to ensure that the wiring is properly grounded and that the circuit breakers are functioning correctly. In addition to these general considerations, there are also some specific requirements that apply to the use of SJ cord in fixture whips. For example, the NEC requires that flexible cords be supported at intervals of not more than 12 inches where run horizontally and not more than 18 inches where run vertically. The NEC also requires that flexible cords be protected from strain by using strain relief devices at the point where they enter the fixture and the junction box. Another important consideration is the type of insulation used on the SJ cord. The NEC recognizes several different types of insulation for flexible cords, each with its own set of properties and applications. For example, Type S cord is a heavy-duty cord that is suitable for use in damp or wet locations, while Type SJ cord is a lighter-duty cord that is suitable for use in dry locations. It's important to select a cord with insulation that is appropriate for the environment in which it will be installed. In summary, the use of SJ cord for fixture whips is permitted by the NEC, but is subject to certain restrictions and requirements. It's crucial to consult the latest edition of the NEC and local codes to ensure compliance and safety. Also, it is of paramount importance that you consult with qualified electricians and local authorities to ensure code-compliant and safe installation. Now let's consider some practical examples of how these code requirements apply in real-world scenarios. Imagine a grocery store with 6,000 feet of track lighting supported by a jacked chain. In the 2002 NEC, if the track lighting used incandescent fixtures without plugs, SJ cord could be used for the fixture whips connecting the fixtures to the track. However, if the track lighting used fluorescent fixtures, SJ cord would not be permitted, and an alternative wiring method, such as flexible metal conduit or armored cable, would be required. In the 2017 NEC, SJ cord could be used for both incandescent and fluorescent fixtures in the track lighting system provided that all other requirements for ampacity, support, and protection are met. Another example is a retail store with pendant lighting. In both the 2002 and 2017 NEC, SJ cord could be used to wire the pendant fixtures as long as the cord is properly supported and protected. However, if the pendant fixtures were located in a damp or wet location such as a bathroom or outdoor patio, a different type of cord with moisture-resistant insulation would be required. A third example is an office building with recessed lighting. In both the 2002 and 2017 NEC, SJ cord could be used to connect the recessed fixtures to the junction boxes, provided that the cord is installed in a raceway or cable tray for protection. The raceway or cable tray would also need to be properly supported and grounded. These examples illustrate the importance of understanding the specific requirements of the NEC and local codes when installing fixture whips using SJ cord. By following these requirements, you can ensure a safe and compliant installation that will provide reliable service for many years to come. It's also important to note that the NEC is not a design manual. It provides minimum standards for electrical safety, but it does not tell you how to design an electrical system. The design of an electrical system should be performed by a qualified electrical engineer or designer who is familiar with the NEC and other applicable codes and standards. The electrical engineer or designer will consider various factors such as the load requirements, the voltage drop, the short circuit current, and the environmental conditions to design an electrical system that is safe, reliable, and efficient. In addition to the NEC, there are other codes and standards that may apply to electrical installations. For example, the National Fire Protection Association, known as the NFPA, publishes a variety of codes and standards related to fire safety, including NFPA 70E, which addresses electrical safety in the workplace. The Institute of Electrical and Electronics Engineers, known as the IEE, also publishes a variety of standards related to electrical engineering, including standards for grounding, surge protection, and power quality. It's important to be familiar with these other codes and standards and to comply with them as applicable. Another important aspect of electrical safety is proper grounding. Grounding is the process of connecting the electrical system to the earth, which provides a path for fault current to flow back to the source. This helps to protect people from electrical shock and to prevent fires. The NEC provides detailed requirements for grounding electrical systems, including the size and type of grounding conductors, the location of grounding electrodes, and the methods of bonding metal parts together. It's crucial to follow these requirements carefully to ensure that the electrical system is properly grounded. Regular maintenance is also essential for electrical safety. The electrical equipment should be inspected regularly to identify any signs of wear and tear, such as cracked insulation, loose connections, or corroded contacts. Any damaged equipment should be repaired or replaced promptly. The electrical panels should be kept clean and free of obstructions to allow for proper ventilation. Circuit breakers should be tested periodically to ensure that they are functioning correctly. By performing regular maintenance, you can help to prevent electrical hazards and extend the life of your electrical equipment. In conclusion, electrical safety is a complex and multifaceted topic. It's essential to be familiar with the NEC and other applicable codes and standards, to follow proper installation practices, to perform regular maintenance, and to consult with qualified professionals when needed. By taking these steps, you can help to ensure a safe and reliable electrical system for your home or business. Finally, remember that electrical work can be dangerous. If you are not qualified to perform electrical work, you should always hire a licensed electrician. Licensed electricians have the training, experience, and equipment necessary to perform electrical work safely and correctly. Attempting to perform electrical work without the proper qualifications can result in serious injury or death.